Okay, we're back from our previous video, continuing with the set of exercises here. These exercises all have something to do with descriptive statistics, measuring size and relative standing. So here we have a survey of 22 different grocery stores, and the number of different types of canned beans were collected. And so depending on the grocery store, they had different amounts of different kinds of canned beans. So what I want you to do first is construct a stem and leaf diagram for the different types of canned beans. Now in this video we're going to have basically I think about 7 different scenarios here that we're going to be working with, and each time I'm going to ask you to do things with them. I want you to press pause, work it out yourself, and come back. These should be review exercises over the things that we've already been talking about. So this is not intended necessarily to be your first exposure to this, but rather a check. So go ahead and do the stem and leaf plot now. So I ran this through a program called Minitab, and it came up with this output. So look at what this gives. Ignore the left column for the moment. Here are your stems, and here are your leaves. So look at the twos. There's 1, 2, 3, 4, 5. So it basically set it up with 5 lines per stem. So here's a stem of 1. There's 5 lines. 1, 2, 3, 4, 5 lines, and so forth. Okay, so if we put these in order, the data we can read off from this. There's 10. One store had 10. One had 11. 2 had 12. Then one had 13. We had a 14. 3 stores had 15. A 16. A 17. 2 stores had 18. One had 19. One had 20. Nothing in the 22 and 3s. We had a 24, 25, a 26, a 27, no 28s or 29s, a 30 and a 31, no 32 or 33, and then we had a 35. Okay, so there's your stem and leaf plot there. It also gives you a total count here, n equals 22, and it has some extra information over here on the left, and let me just kind of explain this. If you take the let's see. This one says there are 2 at this level or below. This is 5 at this level or below. See, if you add those, there's 5. 9 here or below. And this says 11 there or below. And from here, they break it up, and these are what's above. So this one is 11 or above here. And so basically, they'll find the median, and below, from below the median, they'll counting a cumulative frequency from the bottom, and this one's a cumulative frequency essentially from the top, sort of a reverse cumulative frequency here. So they're 11 at this class or higher, 8 at this class or higher, and 7 here or higher, 7 here or higher, and so forth. Finally, down to the last one here. So that's what this is, sort of a relative, sort of a cumulative frequency over here on the left, but this is your stem and leaf plot here. Now in Minitab you can force it to do different numbers of leaves per stem, but it figures out some way of doing this. It figures out a way to do it automatically, and you can change it if you want. Now this is an interesting problem here. We're given a part of a table. We're measuring whatever it is we're measuring, and these are your bins here. 1 to 5 is here, 6 to 10 is here, 11 to 15 is here, 16 to 20, 21 to 25, and I've given frequency, relative frequency, and cumulative frequency, but I've only filled out part of the table, somewhat random parts of the table, and see if from this you could fill out the rest of the table. See if you understand enough about frequency and relative frequency and cumulative frequency to go back here and to fill this out. So I'm going to press pause, fill this out, and come back. All right, there might be more than one place to start. So the first thing I notice is if we add a line for sum, the cumulative frequency for the last part is the sum here. And, oh yeah, this is supposed to already have a 90 here. Well, now, let's see here. we could do a few things else from here. So we have, actually it didn't have to have 90 here. We can figure out the 90. How can we figure that out? Well, this is the total of 200, and this is 45% of that, or 0.45. So we just multiply 0.45 times the 200, we'll get the amount there, which is 90. Okay. All right, let's see what else can we do. Well, we can figure out the lowest one here. The lowest cumulative frequency is always the same as the original frequency of the lowest group. So that was easy enough. Just copy that over. We can figure out some percentages here, but let's see here. If this is 50 and there's 10 here, they're 50 at this level or below, and we've already got 10 of them here. That must be 50 minus 10 is 40 there. And now if we add all these up, or we can do it, let's go ahead and do a cumulative frequency as we go here. We do that 50. That 10 plus 40 is the 50 here. The 10 plus 40, or this 50 plus 40, is 90, is the to here, and that 90 plus, so I can either do it two ways. I can add this 90 and this 90 to get the total 180. Because this 90 is these three added together, or I can just add all of these and get 180, and that's the cumulative frequency. Okay, so now that I have all these, I can figure out, and then I can subtract here. There's 200 here, and I've only added 180 here, so that must leave only 20 there. 200 minus 180. Okay. Now I can figure out all the relative frequencies, and there's more than one order to do some of this stuff. But I can find the relative frequencies by just dividing all the frequencies by 200, and there they are in decimal form. I could also write them in fraction form, which actually I have here, it's not reduced. Or I could do them in percent form. And so we've now completed the whole table there. Now make a frequency histogram for this. Press pause. Well, here's a grouped frequency histogram. Here are our data groups, and we have this. I think I probably constructed this in Excel, but you could certainly do it by hand or using Excel or some other programs. How about an ogive? Remember, an ogive is a cumulative frequency. It starts at 0. And then at the end of the first one, we go up however tall it is. 10. Okay, for the first one. Then the next one we add in the next one, that's a total of 50. So what we're doing is we're just graphing ordered pairs here. Well, this is our input, is that class. And then we're graphing dots at a height of 10, 50, 90, 180, and 200. We could also put a percentage scale on this and put these as percentages here. And of course, if you do it as a percentage, you will end up at 100%. And really, I didn't need this this axis to go up as big. I wonder if I can go ahead and change that. Yeah, that's a little bit better. Because it always is going to end up at 100%. There's no point in making the scale really go up any higher than that. Okay, next question. A stem and leaf plot of the closing prices to the nearest dollar of the first 50 common stocks listed in the New York Stock Exchange with a value between $10 and $99 on July 23, 1998 were given this way. And notice I've given a source. So a source like that is good to list, and then of course you want to have some sort of title, and then here's the actual stem and leaf plot. Okay, and that's one line per stem. There are enough stems in here that I would probably just do 1 line per span. What's the highest and lowest price of those? The highest and lowest stock price for those selected? Well, what is it? The lowest is here, which is 11, and the highest is here, which is 90, and that's dollars per share. Which one contains the most values? Which is this one, which is in the teens. That's from 10 to 19 dollars per share. Okay, let's try another one. The following graphs give information about recent performance of stocks. The Dow Jones Composite Average is tracked, and this is, here's my source here. Pull this off at that particular date. And here we have this graph. Let's see if I can make it a little smaller to fit on the page. There we go. Now you can see the whole graph. Alright, so there's a lot of information here. What's going on? Well, let's see. This is the date here. July 8th, July 28th, August 15th, September 4th, and the days in between here. And this is the level of the Dow Jones average. It's an average price index of certain stocks, industrial stocks. And down here is the volume of trading, which is given as a bar graph on each of those days. Okay, so the one on the top, what kind of graph is it? Well, it's a time series. Okay, in fact, both of these have an input of time, and it's a broken line graph, time series graph. The one on the bottom is a histogram, where the input is by day. So it's a total number of it's a counts of how many stocks in terms of volume and dollars. Not number of stocks, but billions of dollars. So this is billions of dollars here, and then this is some kind of index number there. So I'm not really sure if this is, for example, if this is $10 billion or 10 billion shares. Okay, so you see a lot of ups and downs through the day, from one day to the next. That's or even within a day, you're going to see ups and downs on the value. Okay, that's very typical. But we can see sort of an overall downward trend for this time period. Even though it's going some ups and downs, it's overall kind of not doing as well in terms of it's decreasing in value overall. And I actually computed some actual numbers there. This was the value at the beginning. This is the value at the end. And so we worked out that's about a 7.9% or about 8% decrease over that time period. Okay, let's go on to another question. Suppose you work for a company that manufactures dolls. Lately you've noticed that an increasing number of the dolls are being rejected at final inspection due to scratches, peels, and smudges in the paint. So you want to see if a relationship exists between the type and number of flaws and the work shift producing the dolls. Now this is something that you can do pretty easily in a statistical package. Not so it doesn't work very well in just by hand or with a calculator. It's not even very easy to do in Excel, but if you can put this in a program like Minitab or SPSS or some program like that, it's quite easy to do this. So here's the command, at least for Minitab. You go Stat, you choose Quality Tools, and choose a Pareto Chart. You can find the similar thing in SPSS or in some other packages as well. And you select, when you're doing it, you select a variable to do by period. So there's the day shift, the evening shift, the night shift, and the weekend shift. So there's 4 different sets of workers working on this. Now, remember, in a Pareto graph, it's used for categorical data or nominal data. Okay, so there's not an inherent order of peel, scratch, smudge, or others kind of last, but there's no, usually it's put last, although it's not in these. But peel, scratch, other, and smudge are the categories. Now, there's not an inherent order of that, so we can order it like we want, and we typically order it from highest to lowest. So they're ordered here. You can tell by the colors that they're put in the order peel, scratch, other, and smudge, and that's in the order of their overall decreasing frequency. So overall, there are more peels than anything else. Next, there are scratches, then the other category, and smudges least. Typically, when we do if we have an other category, we usually like to put it last. But if it's bigger than some of the other categories, then we would oftentimes split it apart. So anyway, we do this. But now notice that depending on which shift you're in, even though peel is the biggest problem overall, it may not be the biggest problem for a particular shift. So for example, notice that the night period, their biggest problem is scratches, and the weekend period has no scratches at all. Whereas for example, the evening group definitely does have more peels than other things, and peels are the biggest thing in the weekend. But scratches seem to be the biggest problem in both the day and the night shift. So it's interesting, you see some differences in the shapes of both the cumulative frequency line and the different bars. So, for example, if I were working well, you tell me, what would you do if you were the manager of this plant? What would you do with this information? Well, the first thing I'd notice is that peels and scratches overall are my 2 biggest problems. So I would definitely concentrate on trying to fix those two things. Okay, but I would notice, for example, that the weekend guys, first of all, their numbers are pretty low, and but especially they have very few scratches. On the other hand, the night period seems to have lots more mistakes, period, and their scratches are very high. So what we might do is we might look at particularly at the weekend folks, see what they're doing that's different from everybody else to prevent scratches, and apply that especially to some extra training for the night folks, and see if we can improve scratches that way. Overall, our biggest problem is peels, but not for the day and the night period. That's not the biggest problem. So we might look at the day period, for example, which has a low count of peels, see what they're doing, that we might apply to some of the other groups to do some retraining. So some further training, or there may be some other factor that comes into play why these groups are different. But we definitely see some differences in shape of these distributions. So there is something different happening at different shifts. Okay, now here's the overall Pareto chart when you put it all together. Okay, so peels and scratches actually are both pretty close, 15 peels and 13 scratches. But notice together those two count for 32.5% of all the total thing. Smudges and others are both 6, and normally we would actually write the smudges first and then others second. Others are always last in a Pareto chart, so this is actually backwards. Okay, see if we can actually fill out this chart for percentage, cumulative percentage, and the count that was used to make this data. And actually, it's already, most of it's already given for you right there. Here it is. You check your work. Okay, new problem. I'm sorry, this is new data. I'm sorry. These are the counts. Fill out the rest. It's not the same problem. Same kind of problem, but a different one. First thing you want to do is put them in decreasing order, which we already have. Okay, finish it up. There's the table. Check that. Check your work. Now make a Pareto chart for it. Again, we make a bar graph for each one. And then actually I like to start at 0 here. So then I'd also add a line. I would actually do this. I would take this and Minitab didn't do this for me, but I would insert a I would insert a little line segment here if I can do it. There we go. So I'd put another line segment going from here to 0. Okay, let's format that a little bit so you can see it better. Okay, so I like my line to always, my thing to start at 0 and go up to 100%. So there we have it. A good Pareto diagram. What's the total defect count in the report? See if there's 150 here. The two main things you should focus on are blemish and scratch. Okay, finally, last one for this video. Here's a graph. What's wrong with it? Well, it's almost like, can you find anything right with it? Everything's wrong with it. Let's start with this. There's no title. There's no source. Presumably, this is some sort of frequency, but you don't have a natural scale. First of all, you should start at 0, not at 50. Notice this goes up 50 to 100, 100 to 150, 150 to 200, but then 200 to 300 and 300 to 500 are the same vertical space, but they're not nearly the same amount. Here's it's going up by 50s, and this is something else. You should always start at 0. You should always have a consistent scale here. Now, then you got another problem. Presumably, the heights are where maybe where they belong, possibly. But notice that not only did we make this one bigger in height, we made it bigger in depth as well, and in width. So this is way distorted. So if it's really just a little bit taller, this looks like it's several times bigger than this one, whereas actually it's only just a little bit bigger. That's a very big problem. Okay? No units. What are the units here? What are we measuring anyway? Gooey bars and sticky snacks. Or is this calories? Is this the size of the serving? Is this, who knows? Who knows what it is? And what units is it? Is it calories? Is it ounces? Who knows? We got to have some sort of units with that. And since we didn't start at 0, that's deceiving as well. So there are many, many, many things here about this that are wrong. So basically, you should avoid three-dimensional bar graphs all the way. You should just do vertical bar graphs, two-dimensional. If you want to make it visually appealing, do it some other way. Do it with colors. Do it with backgrounds. Do it some other way. So there are lots of important elements that you need to make with graphs, and there are lots of times people will do these, will put out graphs that are poorly done and they don't accurately represent the information. So make sure that you don't ever do that. Okay, I think that'll finish us up for this particular video.